Hi everyone, my name is Paul Emmanuel and I'm the community leader at Starknet Africa. So today we are in week 5 for our Cairo Bootcamp, and last week we had Nathaniel go through the Starknet development tools like Starknet, Starknet Foundry, and a whole lot of other stuff, right? But this week we are changing the gear to advanced Starknet contract development, which Casweeney will be diving into introduction to composability and Starknet, building modular contract, optimizing storage costs, and a whole lot more. Right. So if you have been following since the bootcamp started, I mean, kudos to you. You guys have been turning up, like making it amazing for tutors to like keep on teaching and all. And today, Kasmin is an amazing tutor, just like every other tutor has been like here with us like so far since week 1 to week 5, and he's going to put everyone through in any maybe question you have. So if you have like specific questions on Bootcamp so far, you can always like ask the tutors in the group on Telegram and all. So Kaswini, are you there with us? Hi, Kaswini.
Hi, Paul. I think you should make him co-host. Probably he's unable to unmute or something.
Yeah.
Okay, yeah, I just unmuted. I was struggling to unmute. All right, I'm here. Hi, everyone. Good evening, good morning, good afternoon, wherever you are. Good to be here. So, uh, are we starting already?
Yeah.
All right, okay. Oh, okay. Yeah. Welcome, everyone. Yeah. So we are about to get into business to start today's class. I'll do a brief introduction. Let me just share my slide because the introduction is in the slide already. So I'll share my screen. Just a moment. Okay, yeah. All right. Can you see my screen? Sorry, let me just set up this stuff so I'll be able to see everything at once. Where is this guy? Okay, yeah. Okay, we good. All right. I don't know. I have this kind of is it deja vu whenever I say can you see my screen? It just reminds me of when we are having stand up and those days when you want to give update in stand up and you don't have anything to say. You just be can you see my screen? Can you see my screen? All right. So welcome to the week 5 of this program, and so we are going to be talking about advanced Starknet contract development. And in the session 1, we'll be dealing with composability and components. All right. So before we move forward, I have a quick disclaimer. In the process of this class, we might, I might encounter errors. I've not written Cairo this year. So while I was trying to test a couple of things, I noticed that most of my dependencies were outdated. So I just updated them today. I don't know if some of the syntax I know have been updated as well, but whatever the case will be, we are going to get to the end of the class. All right. So, all right, let me slide show this guy. Okay. All right, my name is Casweeney Ojukwu. I'm a blockchain engineer, and on Twitter, I'm CodingCast. And today's agenda, this slide is very small, by the way. It's very, very short. It's not up to 6 pages or 6 slides. So today's agenda, we'll be dealing with introduction to composability in Starknet. We'll be talking about embeddable implementations, which is the building rock The building rock of components. Wow, that was an omission. So it's supposed to be the building rock of components. So embeddable implementations are the building rock of components. And we are also going to be talking about modular smart contracts. And this we are going to be learning together. It's not like a garbage in, garbage out. We'll be learning together. All right. All right. So the first part of this guy is introduction to composability and components. So these are just texts. So what is composability? In Cairo, this refers to the ability to combine different pieces of code or smart contract to create more complex and future-rich applications. It enables developers to reuse existing code and smart contracts built on top of each other, or on top of other contracts, and create modular interoperable systems. So for those of you that maybe you're from the, okay, let's not go to Solidity. So if maybe you were writing other programming languages, you know, where you create things like helper functions, right? Where those helper functions, you don't want your code base to be very bloated, and you create helper functions that are inside another file, which you could just call inside the main class or the main place where you want to use that function. So in order to like abstract things, they call it separation of concern. So you don't bloat your code base with so many functionalities. So just picture composability as something like that, where you separate things so that your code base doesn't look very big. Now, let's bring it back to stuff like Solidity. In Solidity, what you could picture composability as, for those of you that are from the Solidity background, but if you're not from the Solidity background, yeah, the example I made with helper functions is will make it clearer. So helper functions in maybe JavaScript or TypeScript and all of that. But from the Solidity background, what is synonymous to components in Solidity is abstract contracts, where you don't deploy them, you can just import them inside the main contract, and you automatically have access to all the functions that exist in the abstract contract. So that's what this composability is trying to talk about. Now, moving over to what are components. So components in Cairo are reusable pieces of code that encapsulate specific features. So sorry, I'll be reading this guy out. This class is going to be heavily on practical. So let me just read this guy, explain, and then we jump into the code. So components in Cairo are reusable pieces of code that encapsulate specific functionalities. The equivalent of components in Solidity are abstract contracts, although they have slight differences in how they are being used, but they share a similar concept of reusable code that cannot be instantiated. You know, after contract, you cannot deploy it. Similarly, you cannot deploy components. You can only use it inside the contract. So that cannot be instantiated and are meant to be extended or used by other contracts. So like contracts in Cairo, components contain storage, events, and functions, but they cannot be declared or deployed. So unlike in the Solidity side where you just deploy a contract, in Starknet, before you deploy a contract, you have to declare it first so that you get the class hash. Then after getting the class hash, then you deploy. So they can only be injected into any smart contract, and they eventually become part of the contract by code they are embedded to. So that's just about components. So components are just small pieces of code that you create that you can import in your main smart contract. And when you import them in your smart contract, all the functions that exist in the component are automatically available in the smart contract where you're using it. All right. So now let's look at, I made the correction here, embeddable implementations, the building rock of components. So, okay, let's proceed. So embeddable implementations, what are embeddable implementations? So that impulse, that if you've been writing, I'm sure you'll be writing Cairo, like from other classes. So you see all those IMPL, that's just a short form of implementation. So embeddable implementations, while components provide a powerful modularity, to smart contract on Starknet, it is dependent on some underground concepts, one of which is embeddable implementations. So take note of this. Embeddable implementations embeddable implementation is an implementation of an interface that can be embedded to any other smart contract. And the functions in the embeddable implementation block are available in the smart contract. So this is just grammar. What it's basically saying is when you create an embeddable implementation and you embed it inside the smart contract, all the functions that you created inside that embeddable implementation will be available in that contract. I know this is kind of confusing. When we start writing the code, it will make sense. So picture embeddable implementation as this abstract contract, or as let's say you have a class. If you're being writing other programming language that are maybe object oriented, let's say you have a class that has methods inside the class, and you now create another class that extends that other class. So once it extends that class, automatically all the functions that are in that class is available in the main class that is extending the. I'm making use of so many English, but don't worry, you understand when we get into the whole practicals. So a summary of a component is made up of one or more embeddable implementations. So example, OpenZeppelin component. I think I will just show you OpenZeppelin component so you see that guy. So let's just take a look at this guy. So this is the same way you have OpenZeppelin for Solidity, you also have OpenZeppelin for Cairo smart contract. So if you want to see the OpenZeppelin packages, or what are that packages are basically components. So just go to packages, and I'm sure you can see my screen, right? If you can see my screen, let me see like 1 or 2 years. All right, good. So now inside these packages, we are just going to look at token. And inside token, I'll go to the source. I'll hit ERC20, and I'll hit ERC20 again. Now, if you take a look at this guy, let me zoom in. If you take a look at this guy, you see that this is using a flag, an attribute. This is called an attribute. So it's using this attribute, and the attribute is Starknet component. It's not Starknet contract, as you guys have already seen before. This is Starknet component. Now, like I said, a component is made up of one or more embeddable implementations. So if I scroll down, you see that we have this guy here. This is an embeddable implementation. This is one. This line 117, when you're seeing embeddable as, is one embeddable implementation. Let's go again. And you see another one. This is another embeddable implementation. And this is another embeddable implementation. And this embeddable as you're seeing, the name you put inside of this bracket is what you will use to embed this implementation inside the contract you want to use it. So don't worry. Take a deep breath. We are going to get into the code and everything will make sense. So I just wanted to show you this to assert this statement here, that a component is made up of one or more embeddable implementation. All right, so let's proceed. Okay, and that's all about that's everything about my slide, right? We are going to come back later, but that's all. So enough with the talks. Show me code. It's time to fire down, buckle up. So before we move into the code, I would like you guys to ask questions, 1 or 2 questions before we fire down. So the time is now if you have any question, because we are done with all the talking. We are going to be writing code next. Any question? Okay, no question. I assume no question. So let's get to business. So I'm going to minimize this guy. I'm going to minimize it. What do you need embeddings for? Okay, so is it the same as using interface? No, it's not the same as using. Okay, let me go with what do you need the embeddings for. So that's the way they designed it in Cairo is that you have to name. So that when you see that embeddable as are you passing the name, it is that name you pass inside that embeddable as that you will use to embed that component inside a contract where you want to use it. That's just the design principles they use. So no, it's not the same as. So let me. I'm still with Chidinma piece. Yeah, all right. So that's just the design principles of how that's how they designed it. So you need to like embed it into your contract using the name with which it was declared or something like that. So, and it will become clearer once we start writing the code. For now, I know everything will be confusing. Now, you say, is it the same as using interface? No. So, interface in normal programming language, in normal programming language, like normal programming language that has nothing to do with smart contract, interface is used for implementation. For instance, if you create an interface and you tie that interface to maybe a class or something, that class is going to throw an error until you're done implementing all the function signatures that are in that interface. That is in normal programming. But in smart contracts, both Solidity and Cairo, interfaces are used for two things alone. You use interface for implementation and use interfaces for interaction. So if you tie an interface to a contract, that means you want to enforce that the function signatures that exist in that interface must be implemented in that contract. But if you just import an interface and you don't tie it to a contract, you can use that interface to interact with an already deployed contract. But the way it works in Cairo is a bit different. So when you create an interface in Cairo, automatically the Cairo compiler creates a dispatcher for you. So it is that dispatcher that you will use for interaction purposes while you use the actual interface for implementation purposes. But in things like Solidity, you use the interface for both interaction and implementation. So I don't know if that answers your question, Mojit. So components are not like interface. Components are just places where in components you implement the functions itself, everything, the functionality are in components. So all you just need to do is import it inside your contract and use it. It's not an interface. Is embeddable implementation same as library in Solidity? No. Embeddable implementation is same as abstract contract in Solidity. Is it similar to classes in JS? So no, it's not similar to classes. When you talk about classes in JavaScript, you're now dealing with object-oriented programming. That's out of the context. Just know that components are just what helps you to create a small. So it's basically modular programming. So if in your normal programming language, you can create small classes. Yeah, you can liken it to classes. Let's say you can create small classes to do particular, to handle particular implementations of functionality. Then you can have a main class where you can now extend that functionality. Then you can liken it to classes. So what components do basically is just enabling you do separation of concern where you don't have to choke everything in one contract and all of that. So you just put functionalities in the component, then you embed it into your contract. So in Cairo, you embed components. In Solidity, you inherit abstract contracts and all of that. Okay, like a contract, library or function that can be imported to any other Cairo program without needing the right logic. Am I correct? Yes, very good. Yeah, Adebakin Olujimi. All right, so creating components in React that. Yes. Yeah, Mojit Fetuga. Yeah, that's correct. All right. I'm really glad you guys are following and it's making sense. Okay, let's get into business. So I'm going to create a folder, call it Cairo Bootcamp 4. Cairo Bootcamp. Yeah, Bootcamp. How do I write it for again? IV. Yes, IV. So let's bring this here. So in this guy, I'm going to create like a very basic project. So I'm sure all of you know how to create a Cairo project. So I'm going to open my terminal at this guy. Yep. So let's maximize this guy here. Sorry, I refer to everything as guy. So if I'm saying let's do this guy, just know that whatever is in the context is what I'm talking about. All right. So now I'm going to do scalable new. Okay, so let me just explain the modus operandi of this class before we proceed. So I'm going to, in order to achieve maximum understanding, like very maximum understanding, so that at the end of this class, everybody will be able to like understand the barest minimum of what components are. I won't just dive into how to make use of components or how to create a component. So what I'm going to do, I'm going to be creating four things. One is I'm going to create an ERC20 smart contract from scratch. Sorry, I'm going through that route, but there's a reason why I want to go through that route. I'm going to write an ERC20 contract from scratch without components. Now that ERC20 contract, we are going to implement all the functions that makes up a basic ERC20 contract. Then secondly, I'm going to write an ERC20 contract that is using OpenZeppelin component. So you are able to see the difference, the one with component and the one without component. Then we are going to create an embeddable implementation, and we create a contract that uses the embeddable implementation. Then lastly, we are going to create a component, and we are now going to use the component in a contract. So this is the route we are going to go through. So that's why I say you guys should buckle up. It's a long journey. We might not finish everything today. Wherever we stop, we'll continue it in the second section before we move into upgradable smart contract, which is also a way of using components. All right, are we good? If you're excited, can you? No, my camera. So my first screen is where I am writing the code. That is my laptop. But on my monitor is where the Zoom window is. So if I'm talking to you guys, I'm looking at the Zoom window and I need to see the persons that are chatting and all of that. That's why I kept it on this other side, right? So, but my laptop is where we'll be writing the code and all. So yeah, let's proceed. All right, so I have created that guy. I'll now open this guy. Have I? Oh, I've not created it too. Oh, sorry. All right. All right, scab new. Let's call it ERC20. I'll name it no components. there's 20 no components, right? So scalable has 20 no components. But before that, I'm sure, I don't know if you guys can see this stuff. Let me zoom in so that you see scab new ERC 20 underscore no underscore components. All right, let's go there. So I'm using Starknet Foundry, which is the default. All right, we're good. Okay. So let's close this guy, open up this guy. So this is what we created, and I'm going to open this guy up. Aha, yeah, here we go. Okay. Please, in the course of this whole class, if maybe you have any question as we go proceed, just drop it in the comment section so I can pick it up, so that I don't implement, and when I'm getting to my bus stop, will now start going back to where I booked the ride. So yeah, wherever you have any confusion, just let me know immediately so we can tackle it. All right. Okay, so let's fire down. Can you guys type fire down, please? Let me know you guys are following. How many persons are on this call? Please let me know. Type fire down so we can fire down. Nice. All right. Yeah. Okay. All right. So let's get to this test. All right. So let me zoom in. All right, you already know the whole Cairo boilerplate. So when you create a new Cairo contract, this is what you see, and you have already been told that okay, for you to write a Starknet contract, you need an interface because you must always use an interface. You need an interface. It is the interface that will guide your implementation. This here is your implementation. This guy here is your implementation. And the reason why you have this attribute here, this attribute is trying to tell this whole block that in all the functions in this block can be called externally. That's what this attribute here is doing. So I'm going to get rid of this guy, right? I'm going to get rid of this guy. So the first thing we are going to do, we are going to create an interface for our ERC20 token. All right. Energy they cry. So we are going to create an interface for our ERC20 token, right? So the first thing we are going to do, we are going to create a trait, and that trait we are going to call it. So interfaces start with I, so I'm going to say I test token, right? And it needs to take in a generic. So that generic, you can use T state if you want, but most contracts use T contract state, right? So, and the reason why you're creating I don't need to explain this contract, but if I don't explain it, most of you might not understand. So let me explain it. So the reason why you're creating this guy is so that if you want to implement, you can pass in your contract state. Unlike Solidity, where everything in your storage is your state. In Cairo, your state, like you have to pass in your state. Your state is like a struct. And whenever you declare the Starknet contract, automatically you have access to the state and all of that. And your storage, you have to create a struct and you label it storage with a storage attribute. That's where it becomes storage. So it's a different paradigm over here. All right, so we have this guy. So what we need to do now is basically create our function. So the functions that make up your ERC20 token, let me just go and copy it somewhere, please, because writing all those guys, it's gonna take a lot of time. So I'll just pick it from somewhere. Right. All right, got it. Yep. Aha. So now these are all the functions that make up a standard ERC20 token. Can you guys see this, or should I zoom in again? Is this clear enough? Please, guys, let me get your response. Let me see. Oh, zoom in. Okay. All right. So I like seeing like higher. So this is what the functions that makes up an ERC20 token. We have total supply, balance of, allowance, transfer from, approve, name, symbol, decimal, so that you can know if you want to be able to call me externally. And the reason why these guys complain is because we are making use of a type here that we have not imported. Like I said, it's the log I wrote. I've not written Cairo this year. So use so it's use call dot Starknet contract address. Why is it complaining? Usage of deprecated feature called internal use. So I said it. Oh, I need to reference. Sorry, just a moment. Let me reference something. Let me check this guy. Where will I see opposite plane? Let me see. Okay, they are no longer using core. All right. Okay. They are no longer using core. Aha. Here we go. So those are no longer there, right? All right. So let's continue. Do I need to make this public? Let's continue. If I will need to make it public, the compiler will tell me as we proceed. So the next thing we are going to do, we are going to say we want to create now we want to create our contract. So, and remember that Cairo is an extension of you guys wrote to remove core. Yeah, Cairo is like an extension of Rust. So everything are in module, like everything are in modes. So mode is like a separate container. Everything inside there belongs to me. And when you create another mode, everything inside that other mode belongs to that mode, like separating things. So the same way in Solidity you do contracts, everything inside that contract block belongs to that contract. You create another one, everything. So that's how you do this guy here. So don't say mod. And inside mod, we are going to call it test token. Test token. Right? And this test token is the block, but this is supposed to be as in brackets Starknet. Okay, I love this. This compiler is good now. It's very, very good. Okay. All right. So let me see the error. Must define storage struct. Okay. So we are going to say struct. Public struct storage. Storage must be annotated with. Wait, must be annotated with what? Storage. Just copy this guy here. Let's proceed. No time to waste time. All right. Okay, we good. All right. So this is our guy. So I'm just going to go copy the storage you need, because there's no point trying. What I want to show you is I'm not teach you how to write this contract. I'm just showing, I want to show you the difference between this one and the one with component. So I'll just go copy this guy somewhere. Where is it? Yep. All right. Okay. And why are we having this error? Okay. All right, I'm coming. So I'll just pick some stuff and put them here. I know why. So first of all, before you make use of map, you have to import it. Before we don't have contract address imported here as well. This same guy we did here, we need to bring it here too, because this is a separate space. So we'll bring this guy here. So contract guy is fixed. Then for the mapping guy, you say use Starknet. Oh, let me copy this thing. So, yep. All right. So we have this map here, and that's why. So what is basically happening here is balances. So no, I'm not teaching you guys how to write this contract. I don't want. I'm tempted to start doing a lot of explanation. Please, I don't want to do that. Let's continue. I don't want to do plenty explanation. You guys are good. Olumide, Alfred Olumide, nice. Yeah, it shows you guys already know what's happening. So now we need to create our event. I'll just pick this guy and paste it here. But I'm not writing this contract again. I'll just be copying and pasting. All right. So we have, this is our event, transfer event and approval event. And in Starknet, events like this, now I'm going to create a struct for this event that is going to hold the fields of the event for both transfer and this guy. So I'm just going to copy that as well and paste it. My fear is let this thing not encounter an error that maybe the syntax I'm using is outdated, because where I'm copying this thing from is like contract I wrote long time ago. Yeah. Okay. So now we have this guy here. So we have our transfer, we have our approval. So these are these guys and all, and we good, right? So let me see what is missing. All right. So the next thing we are going to do, we are going to create our constructor. So like, you know, a constructor is a function that is called once the contract is being at contract creation time. That's when constructor is being called. So I'll just pick constructor and paste here. So you guys see this guy. Yep. All right. So this is the constructor. Get caller address. Where are you? Get caller address. Okay, yeah, got you. So all you just need to do here is put this guy inside curly braces and say get caller address. Now, get caller address, what it does is it gets the address of the person that is calling the contract at that time. Get caller address is the same thing as msg.sender in Solidity. That's what get caller address does. So if you didn't write Solidity before, now when you're interacting with a smart contract, you know, for you to interact with smart contract, you connect your wallet, you know, to sign transaction and all of that. The address of that wallet you're using to interact with that contract at that time is what this get caller address is going to return. So let's fire down. So this is basically cash token, CFP, blah, blah, blah. So what I'm doing here now, watch here. I have all of this in my state. Token name, symbol, decimal, owner. They are all here in my state. Token name, symbol, decimal, and this is the owner. So whatever at contract creation time, I'm just like setting the value of those state variables. That's what I'm doing here. So, and here also I'm setting the owner to the person that is that is deploying the contract, and that's all in the constructor, and life goes on. All right. So now Let me check if there's any question. All right. So now we are done with this part. We want to now move into the implementation block. So in the implementation block, I'll just do implement token, so test token, IMPL, test token implementation of super colon. What I want to bring from that super is the interface. So what I'm doing here now, I'm binding that interface to this implementation block, which means all the function signature in that interface must be implemented in this implementation block. And now, remember that interface has a generic, but now we are not using generic again. We are passing the main thing, which is our contract state. So what you're telling it is that this implementation should have access to our state, the state of this contract, and you do this guy, and that's all. And once you do this, we are set with our implementation. Now, this error here is trying to tell you that not all trait items are implemented, missing total supply, balance of allowance. So once you implement all of them now, this error will go away. Are you guys following? Does it make sense so far? It makes sense. It makes sense. I'm sure it makes sense. All right. So, yeah, you guys already know how to write contract. There's no need writing this thing and explaining all the contract individually. So I'll just copy and paste. Okay. Is it like is? Yes. So that implement token implementation, that off in this case is the is in Solidity. Does that make sense? Hey, it makes sense. All right. So here you're using off. In Solidity, you're using is. It's just, you know, what do they call those things in English again? Is it preposition or they are not conjunction now? I can't remember it. It can be preposition or one of those things. All right, so I'm just copying all the functions and I'll paste it there. And yep, let's go. Here we are. So I've pasted all of that. And why are we still having error? Shit. Okay, so let me just walk you through. So remember our interface has total supply, and this is where we implemented the total supply. What it's basically doing is it's just reading from state. So self means this module. When you're using self, it means this module. Self means me, myself. So I'm reading from myself. And self, the total supply, that means you're reading the total supply from this storage, right? And read, you're reading from it. So that method read means read whatever is in that guy. And remember also that in Cairo, if you want to return something, you don't put semicolon. You see, as I added this semicolon, it threw an error. So if I remove the semicolon, it's not going to throw an error. But if you like the syntax of using semicolon, all you just need to do is put return in front of it and put your semicolon. It's the same thing. You see it's working. Yeah, and that's it. But me, I like that other shorthand method that doesn't have return. So people that are coming from other programming language will not just come and understand my code straight and you have to go through Cairo Boot before you know what is happening here. So without the semicolon, just write whatever you want and it's going to return it. Similarly here, that's what I'm doing here. I'm setting the balance to this guide. I'm just returning the balance and all. So this is what it looks like. I think this error is because, so why I'm getting that error? There's a way to get address 0 in Cairo. You know, in Solidity, you just do address 0 and you get 0 address. But in Cairo, there's a way to get it. So I'll just add that here. That's why that guy is showing that error. I'm picking this from my GitHub, so I won't know. Hope it doesn't fail. I just pray it doesn't fail. I pray it doesn't fail, please. I hope it's still the same. Okay, so I'm gonna paste this here. And we're good. So this is a trait. When you get this trait, with this trait, you can get zero address in Cairo, and this is it. So when you get 0::0, this will return a zero address. Now, this right now is an standard ERC20 contract, but since it's not from OpenZeppelin, the same way you cannot just write ERC20 from scratch by yourself on Solidity, you like using OpenZeppelin because of standard. So, but this is a standard ERC20 that has all the functions of an ERC20 token. So, and this is it. If we go over here now to, if we say scab, is this scab compile, scab build, yes, scab build. It's going to run perfectly. Please, no errors. No, okay, good, no errors. So this is it. Let me delete this guy. So this is our ERC20 token without components, right? But now, if you write an ERC20 token by yourself, people might, it's not following standard. And the best way to write ERC20 token without going all through this process is just basically using a component from OpenZeppelin and embed it here. So what we are going to do next is to now rewrite an ERC20 contract that is making use of an OpenZeppelin component. We're not going to write all of this whole stuff here, and you see how sweet that contract will look. We are not going to test anything today. We are in the next class. We will start talking about testing. Okay, yeah, Mitch. Yeah. So address 0 is, addresses are made up of hexadecimal combinations. So address 0 is like an address that doesn't have private key and all of that. It's just a 0 address. It's just 0. It's just hex in zeros. That's what address 0 is. Yeah, and that's what Joseph pasted here. Okay. So that's one. So I'm going to close this guy now. Or let me just leave it so we can reference it. So let me go back to my desktop, which was where I created this guy. So I'm going to create another Cairo project. Open my terminal at this guy, and I'll zoom in, and I'll say scab new ERC20. I'll now say OZ component. OZ means OpenZeppelin, please. So I'll call it OZ component. So for this one, we are going to be using OpenZeppelin components. So yeah, we go, and we good. All right. Let me close this guy again and go back into this guy. OZ components. All right. So good. All right. So for this guy, please guys, pay very close attention because it's about to get very, it's very simple, but it's very tricky. Very, very tricky, right? Please pay close attention to, yeah. All right, so let's go to this guy. Now, this is our boilerplate guy again, and I'm gonna get rid of it, right? I'll get rid of it again. I'll save. So, what I'm gonna do here now is let me get OpenZeppelin. library and add it to my scalable.yml file. So I got Open Zeppelin library. That's the latest library, and I'll add it here. So this is how I know how to add dependency. I think you can do something like scab install or something, but I've not used it. I heard that you can now do that, but I've not used it before. So I don't want to, it's not in this class, I'll try it. Let it not go and fail me. Hey, scab add. I've not used it before, so I won't do trial and error while teaching you guys. I'll use the pattern I know. All right. I'm going to add it here. So once you add it there, you have the dependency, the compile, Scab will compile, and you already have that guy in. So what I'm going to do next here is I'm going to say so in this case we don't need an interface. In this particular one now, we don't need an interface because we are not creating the contract from scratch ourselves. We are basically just bringing whatever is in a component and using it here. So what I'm going to do is, but our mint function, so the mint function in the component is not an external function. So we need to create our own mint function. Then inside our mint function, we are now going to call the mint function of that component. Similar way, your Open Zeppelin ERC20 contract doesn't have an external mint function in Solidity. It has what we call underscore mint. So when you're using it, you create your own mint function and call the underscore mint or something like that. I can't remember, but I'm sure I've seen something like that before. Yeah. So let's proceed. So for our main function, we are going to create an interface. We are going to say trade. We are going to say trade. We are going to say what should we? Can someone suggest a name we call our token? The name of the con. Let me say IOZERC. This name OZER. No. I test. No. I test ERC20. ERC20, right? And we are going to give it a generic of T contract, a generic of T. It's raining, no. Sorry guys, it's raining over here. If the rain gets heavy, I might go offline because this guy we are using doesn't work well with rain. T contract state. All right. So so I'm now going to say FN means, right? FN means, and mean is, I want to ask a general question. Let me see if you guys are good with, are already very good with this guy. A general question. Can you guys, what is the difference between why do we use ref in this function, and in this one we are not using ref, we are just using self, we are using at. Let me just know what's up. Why are we using ref here and we are using ref self, but here we are only using self, and here we are using the generic itself, but here we are using at? Yes, making reference, but why are we doing it? Yes, okay, that's correct. But why are we using at here? What is the meaning of at? What does the at stand for? Okay, ref, you can update the state, okay? Snapshot, okay, very good. You guys are good, Nice one. Okay, nice one. Yeah, this is good. All right, so let's continue. So we are going to do ref self, because mint is basically modifying state, and we are going to say T contract state. Oh, I don't like typing a lot these days. if I already have that thing I want to use. So means we are going to say recipient, right? Our recipient is going to be an address, which is contract address. And how much do we want to meet the person? So we are going to say amount, and amount is going to be U256. I'm not supposed to be coding this out. I just need to copy and paste. All right. All right. All right. So now we have our interface for Mint. So the next thing we want to do is we want to now create our contract. So we say mod test ERC20. Remember the other one we called it test token. Test token. So this one is test ERC20. So test ERC20, we do this guy, but we need to flag it with Starknet contract, right? Yep. So once you flag it with that contract, it's going to tell you the things it's supposed to have, right? Right? All right. So we are going to now say struct storage, and we do this, and we need to flag this also with the storage flag. Okay, storage, just storage like this, are we? Storage. Yeah, this is good. All right, so this is where it gets to now. Guys, pay very close attention. So now we want, so this rail is, I'm hearing this rail. So guys, just a moment, let me close my windows so that I'll stop hearing the sound of this rail. Oh, don't worry, let's continue. No, it's distracting me. Just a moment, let me close my windows. All right, I'm back. So let's continue. I'm still hearing the sound of the voice. It's very minimal. All right, so we have created this guy. Now, please close attention, because this stuff, the moment you don't understand it, you might have a bug on this guy and you sleep here. And trust me, ChatGPT doesn't know Cairo. All right, let's proceed. So what I'm gonna do now is I want to import the OpenZeppelin component. I'm going to say use. So if you see here, the name I called it here is OpenZeppelin, right? So I'm going to say use open, pick this guy up. So I will not go and type the wrong thing. Use OpenZeppelin, right? Colon. Now what we need is token, token, right? Now inside token, we need ERC20, right? Now inside ERC20, these are all the embeddables available. These are all the embeddables available. Now let me show you guys something, quick one. Where is this guy? Please, can you guys see this guy? Can you guys see my screen? Hello? All right. So now, let me show you something. A very quick one. Let me get close to the screen. If you look at this guy, inside this guy, we have this component, right? And if you scroll down, there's something else you have. You have this, look at this ERC20 hooks empty implementation. Now, this guy here, without you importing this thing, you're going to have serious errors. Your code will not work. I don't know why this guy is this way. But you have to import this before it will work. If you don't import it, you have errors. So pay close attention. So you're importing the component and also that hooks empty implementation. And if you look at it, it doesn't really have anything. It doesn't really have anything. So let's go back to this guy. So So we are importing two stuff. So we are importing the ERC. Let me just copy it from there. This is what we are importing. This guy, the component. And we are also importing the other guy. The one at the bottom, the last part of the script, this guy. So we want to make use of OpenZeppelin components. That's step one. Now, step two, this is using components, but I've not explained it though, but in the process of creating components and all of that, I'm going to explain it, but I want to just show you guys. What I'm doing now is called set induction. So, let's say if I want to teach people how to play basketball, right? I can just bounce the basketball into the court and I'll tell somebody to come and collect the basketball. And when I dribble the person very well and the person can't collect the ball, the person will now want to know how to play basketball the way I play it. Then I'll start teaching basketball. That way I've gotten the person's interest. So what I'm doing now is set induction, whereby I'm trying to show you guys how to use components in a contract before we start learning how to create components and why most of the things you guys are seeing are being used the way they are. So that's the flow, right? All right. So now we have imported the component and this hooks implementation. So the next thing we are going to do, we are going to call a component macro. That component macro is what we are going to use to link, we are going to use it to link this smart contract with that component. Now we just imported it. We have not linked the both of them together, right? So we are doing two things. We are doing linking and we are doing embedding. So I'll show you the part where we'll be doing embedding. So now let's link it together. So we are going to say component, right? This is the component macro. So anything that has this quotation stuff is called a macro. So inside this macro, we are going to create a path. Now this path is all of this. This path now is this, from here to this place is the path. But because we have already imported it, we don't need to pass in the entire path again. So I'll just bring this guy and put it here as the path, right? Then the next thing we are going to do, we are going to create storage. Now, what storage does, your component has storage. What you want to do, you want to link the storage of your contract to the storage of your component so that both of them, so in this contract, you can access everything in that component storage. That is the next thing we are going to do. So we are going to say storage. It's easy, right? It's easy. I'll now say storage ERC20. And any name you use in this storage here is the same name you're going to use in this storage. So let's see how it goes. Don't worry. Then the last thing we are going to do, we are going to link the event, this contract to the event of that component, so that from this contract, you can emit the event in those components. Sorry, in the component you are importing. So we are now going to say event inside ERC 20 events, and that's all. Now this is going to throw error because we have not done the linking. So let's link it now. Inside your storage, right, you are now going to create ERC 20. I am now going to link it to this guy. This component you got here, colon, storage. That is the linking. Why is this one still throwing error? Okay, storage. This thing should not come and show itself now. No. Okay, yeah. Now, this storage, you see this storage now, this storage is not the main storage. It is not the main storage. So you need to let this contract know that this storage variable is not the main storage. It is a storage from component. And to do that, you make use of what we call sub-storage. It's an attribute. It's an attribute. We call it sub-storage. And you do V0. Right? This should work now. Hey, please let me just copy it. If I've not typed nonsense, let me just copy it somewhere. Why is this throwing this error? ERC20 is not a sub-storage member in the contract storage. Consider adding to storage. It's now a sub-storage now. This one will be from my compiler. The compiler is misbehaving. It has been added. So the next thing we are going to do is we are going to now link the event too. So for the event, we are going to create an event enum, call it event, right? And inside this event enum, see the name we named the event here. You see it has gone, it's the compiler. The same name we used here is what we are going to call our event. So we are going to name this event. And this time we are going to link it to this same guy. Remember, it's the component event we are linking it to, right? And we are going to say colon, event, right? And now we need to add all those attributes for event. Let me copy it. So we are adding all those event attributes, right? But now, because this event is from component, we need to mark it with an attribute called flat. Yeah, and we are good. Now, like this now, we have done the linking. What we just did now is we have linked our contract storage with the storage of the component, and we have also linked our contract event with the event of the component. This is what we just did here. Now, let me show you something. If you change this to cars, you are going to have error. So you have to change this also to cars. If you change this to anything, let's say you call this cars event, you also have to change this to cars event. So this is where the linking is happening. Is it making sense? Is it? Yeah, I know it's a lot. Yes. Yeah, when I was learning about components, I was like, why? But when I understood it, everything became very simple and straightforward. I even have an article that if you read that article, you will know composability and component like the back of your hand. All right, so let's proceed. Let me undo this guy. Please, no, any question, no question. Let's finish before you ask question. Aha. All right. So now we have done the linking. How do we now embed? How do we now embed? So first things first, in our other function, we have constructor, right? So let's also create a constructor for this guy. So we are going to make use of the constructor attribute. And inside here, we are going to say function constructor, right? And constructor modified state. So it's going to be ref self. And it's going to be taking in contract state, Like Cairo is lovely. Very who agree with me that Cairo is easier than Solidity? Very lovely language. So now guys, watch something. Pay close attention. If you're following, let me see a yay. Just yay. Say yay if you're following. Let me see the number of persons that are following. 1, 2, 3, 4, 5. Only 5 persons. 6, 7, 8, 9, 10. 10 persons. 11, 12, 13, 14, 15. 15. We have more than 15 persons here. 16, 17. I want to get it to no, country cousin. We are on 16. No. I want to get it 20. If your follower is saying yay, you that say you missed the question, that means you're not following. All right. So we want to do something with the constructor, right? And since we are making use of, remember, we are making use of a component, right? So that component should have a constructor, its own constructor. And fortunately for the OpenZeppelin component, they have theirs, and the constructor is called the initialize. I think it's the initializer. There's a function in that component called the initializer. Let's check it. Let's check it out. So this, let me scroll down. Let's look for it. This is embeddable as transfer from approved. No. These are. Oh, sorry. Where is this guy? There's something I'm looking for. Let's go down. It should be down. Down. Aha. So you see, initializes the contract by setting the token name symbol. To prevent reinitializing, this should only be used inside of the contract constructor. So this initializer is the function that you will call to set all these things. For those of you coming from the Solidity background, sorry if you're not from the Solidity background, but let me just say this. For those of you coming from the Solidity background, when you import an abstract contract that has a constructor, in your own constructor, that is where you are also initializing the constructor of that contract. So in this case, this initializer is the constructor of this component. That is what is happening here. So, and guys, constructor are only called once, but you cannot create a constructor directly inside the component. That's why they made use of this initializer function. And for us to make use of it, all we just need to do is, inside here, we are going to say self dot. Remember that with this ERC20, we have connected this component to this guy, which means all the functions in this component, we have access to it. the functions, like the functions that are not inside embeddable. These ones now, like these ones, they are not inside embeddable. They are just implemented so we can access this, right? So all we just need to do now is say self dot this guy dot initializer, right? And initializer takes what? Initializer takes it takes name of the token and the symbol of the token, right? So all we just need to do is inside here we are going to say byte array. I'll say coding class, and the second one is a symbol which is also byte array. I'll say CDC. Why is this one throwing error me? Why is this one throwing error now? See this compiler, initializer method not found. I don't understand. Why is it not found? Why are you not found? Am I missing something? Am I missing something? Wait. I'm coming. Let me check this guy. Let me look at this guy. So we have this guy, implement this guy. Oh, I see. Okay. Oh, you still need to embed. All right. So the reason why we don't have access to this initializer function is because we have not embedded. So we need to embed. Remember, I said, let me just write it here. For you to make use of a component, you need to do three things. You need to import, you need to link it with the component. You need to link your contract with the component, and you need to embed the component inside your contract. What embedding does is, the moment you embed, all the functions inside that embeddable will be available in your contract. So now we have not embedded. That's why we don't have access to the functions. And you can embed in two ways. One of the way you embed is you embed functions that you want to be exposed externally. Secondly, you embed functions that you want to, like internal functions. You know, you can't expose internal functions, so you embed them internally without, exposing them externally. So the first thing we are going to do, let's embed the internal function. So let me just copy this guy. I'm going to put it here. Right. So now you see that what we did here, this is the name of our implementation. ERC20 internal implementation is equal to ERC20 component, which is this guy, colon, internal implementation, and you pass in your contract state. Now let's go to this guy. This is what we embedded, internal implementation. Now with this internal implementation, we have access to all the functions inside this internal implementation. Now you see we have initializer, we have this mint, we have this bond, and we have this update and all of this. Now note, mint and bond are internal functions. They cannot be called externally. The same way you have underscore mint and underscore bond in Solidity, OpenZeppelin, ERC20. These ones too are internal functions, right? But all these ones that you have embeddable as, they are the ones you can embed as external functions. So after we have done this embedding, you see that this guy is no longer complaining. That is one side of the whole thing. Now, the second way of embedding is we want to now embed the external functions, all those total supply, name, balance of, transfer, and all of that. Those are the functions, the implementations we want to embed now. So now we can embed any of this. We can embed this ERC20 implementation, or we can embed There's 20 metadata. So the metadata implementation has name, symbol, and decimal. But the reason why we don't need to embed this is because this one has total supply, balance of, allowance, transfer from, approve, but it doesn't have name, symbol, and decimal. So if you want to embed this one, you have to embed this first one and this second one. So let me just show you what I'm talking about. Okay. So I'm going to say implement ERC 20 metadata, right? And I'll say this is equal to ERC 20 component. ERC 20 components, colon. Now let me go and copy the name, the one I want to embed. I want to embed this metadata. So this is the one I want to embed. So I'll now do this here, and I'll now pass my contract state. Contract state. So this metadata stuff, why is this thing showing me error again? Skip tokens. Why? I'm coming. Let me add this stuff to it because this one is external. My compiler is messing up. Sorry, my compiler is taking time to resolve this guy. I was thinking there's an error. So now what we just did, we just embedded this metadata implementation. And with this stuff, we only have access to name, symbol, and decimal for this guy we just embedded. And this stuff we embedded now, you cannot call this externally unless you add this attribute to it. So once you add this attribute to it, you're telling me that if all the function inside this embeddable should be called externally in this contract. So this is what makes this guy to be accessed externally. But now that we only have access to name, total supply, and symbol, what if we want to access, transfer, approve, and all of that? That means we have to embed again. So we are now going to say, we are going to embed again. We are going to do this. Just keep this guy there. And we are going to say implement. Now we'll call this ERC 20 main functions. You can call it anything. As 20 main functions is equal to ERC 20 component, colon. Let me pick the one I want to embed. So I want to embed this guy now. I want to embed this ERC 20 implementation, right? So you see that what I'm copying is this name inside the embeddable lab. So I'll copy it and I'll bring it here and I'll pass my contract state. Contract state. Now with this, we now have all the functions inside this. We have total supply, balance of, allowance. We now have it inside our contract. But you know, this thing is just a lot of stress. Instead of embedding this one after the other, there's one embeddable that already combines everything. So let me show you. There's one embeddable that already combines everything. It is called the mixing implementation. This particular one is called the mixing. If you look, it has total supply, balance of, allowance, transfer, approve, name, symbol, decimal, total supply. So it has total supply for camel, for snake case, and total supply for camel case. Because, you know, in Cairo, the mostly accepted pattern of naming stuff is snake case. But if you use snake case, your decentralized applications like what is it called? Like agent wallet or Bravos will not recognize your ERC20 token balance. So you have to make use of balance of, that is the camel case. So that's why they added it here. So you can either use any of these or this one to call it. There was a time I wrote an ERC20 token. I was testing it, I minted, but when I checked agent, I wasn't seeing the balance. And everything was working. I asked questions in the Starknet All-Stars group. I wasn't getting answers until, I don't know how, I just said, let me make use of that mixing implementation. When I deployed it, I now saw that I was now seeing balance. That was when I now knew that, okay, the function that those decentralized applications are calling for ERC20 token are the ones with camel case, not the ones with snake case. That's why you need to add it. So let's now make use of the mixing implementation. So you see, this one is camel case only, if you see it. But this mixing has everything. So I'm going to embed this one now. So you see what will happen. So if I embed this guy now, and I say implement everything. This is just a generic name, any name. Implement everything is equal to the ERC 20 component : I paste this guy and I pass in the contract state, right? There's going to be an error. Okay, no, I've not exposed it. Let me expose it. I'm expecting an error. I should get an error. If I don't get that error, that means something is wrong. No, I should get an error. I should get an error. Wait, let me compile. I'm coming. I'm supposed to get an error. Scab build. I'm supposed to get an error. I should get an error. Yes. So look at the error. I think the compiler has not responded because it's supposed to be read. This is the error. Failed to generate ABI, duplicate entry, total supply. This is not currently supported. Now, do you know why? We have already embedded total supply is already here, and it is here again. So you cannot have two functions with the same name. Are you guys following? Please, if you're following, just react, say something, because these things are very, very important. So this embeddable we use there has total supply. This one also has total supply. So you cannot have two functions with the same name here. It's not possible. This is to show you that what we embedded is actually working, right? We already embedded this guy here. Now let's remove this. You see that it's going to complain about name or symbol or something. Let's remove this. Okay, total supply. Wait, where is total supply? Let me know what to remove. Total supply is not in metadata here. Total supply is in the first one. So this is the one that is complaining. So let's remove this. If you remove this, it's going to complain again for name and symbol, because this one contains, where is it? Oh, sorry. That's not the one I'm supposed to remove. This is the one that contains total supply, right? So now it's going to complain for name and symbol, or name or symbol, because this one contains name, and name and symbol is also in this mixing. Let's check it again. All right. So duplicate entry name, because name is here and name is also here. So we don't need this again. So anytime you want to embed, it is always advisable to embed the mixing implementation, because it contains everything. Instead of embedding metadata separately, embedding camel case separately, embedding the other ERC20 separately, just embed mixing so that you don't have to bloat your contract with so many embedding. So with this now, we have embedded the components. And with what we have now, we have a standard ERC20 token. With this now, we have an ERC20 token from OpenZeppelin. Let's build again. It should work now. What's wrong with this? Oh, I have not saved. I have not saved. Sorry. Do this guy. So Scab eats memory like mad. I was running Scab build today. Could you believe that my laptop background changed to black because of out of memory? And it was now telling me to shut down some applications because I was running Scab. All right, so it has compiled now. I know. So with this, we have finished our ERC20 implementation. So we don't need to do any other thing. Just clean it up, and this is it. And all. So what we just need to do now, let's add the mint. Remember that we needed to add mint because that other guy has mint, right? So now all we just need to do is we just say implement what is the name of this contract again? So let me change this thing now. Let me not call it test. Let me not call it everything. Let me just call it ERC20 ERC20 implementation. And a lot of time it's good to use the same name so that you know the exact embeddable you use. So I'll just use ERC20 mixing info so that once I look at it, I'll know, okay, it is the mixing that I used here, right? All right. So now I want to say implement implement this guy info of super colon this guy. We want to make use of that mint. So keep this guy here, right? And we pass in our contract state, and we do this guy. So all we just need to do is, let me just copy this guy here. So I'll just paste this guy here, and this will be contract state, no longer T, and this will be this guy, contract address. So let me just bring contract address here too. Bring it here. So, and inside here, we have our mint. So how do we call our mint? All we just need to do, remember everything is accessible through this storage variable, right? Just say self.erc20.mint. Mint is the name. And what does the mint function take? Where is it? Go down. What does the mint function take? The mint function, where are you? The mint function takes the recipient and the amount. So just come here and pass in the recipient here and the amount here, and we are good. And that's all, and we are good. So let's tab build, and everything should work. Everything should work. Okay, so this is the reason why this took time is because I am explaining how to embed. Yes, so we just embed the mixing implementation. You don't need to, unless you want specific stuff, but the mixing has everything you need and all. So the reason why this took time is because I'm explaining everything step by step. If I wanted to implement this thing, I'll just go straight up and I'm done. Instead of coding all those stuff we did in the other guy, we just do this and that's all. This is the same thing as importing abstract contract in Solidity and doing this contract is the contract you imported, and that's all. This is the same thing. So with this, we have embedded OpenZeppelin here. You will need to watch this video again. You will need to read the article I wrote if you want to understand the inner working mechanisms of components. Yeah, you need to take your time and go through this again. So before we proceed, any question? I know this is a lot. Any question? If you have a question, you can unmute your mic and ask your question, though, if maybe you can't type it out. Yeah, it's expected, but yeah. That's why it's called advanced. So takeout. Let me just list out the takeout for you here. Let me just like list out the takeout without explaining everything. First things first, you need to import the dependency. You need to install a dependency of, OpenZeppelin in your Cairo. You make use of OpenZeppelin or something like that. Yeah. So you need to first install, in your Solidity, your hard hat or your Foundry, install the dependency. In Cairo, the same thing. So this is a dependency here, which is OpenZeppelin, because this is from where you're going to import the contract you want to embed, right? Now, once you import this guy, once you've installed or add this guy to your dependency, you can now import it here. This is how you import. And if you're importing the components you want to use. For instance, if I want to import Oneable, watch now, if I want to make use of Oneable component, what I'll just do, I'll just say use OpenZeppelin, : Oneable should be under access, : Oneable. Can you see it? I'll now say : I'll import Oneable components. And that's it. The same thing I did with this guy is what I'm going to do here. Now, once you import Oneable components, the second thing you need to do is to link it. Pay attention. First thing first is add the dependency to your code. Let me even write it. Where should I write that? The steps. Add the dependency to your package. So this is your package. This whole scab stuff is your package. You add a dependency to your package. Second thing you do, you import the dependency in the contract where you want to use it, which is the same way we did it there, and that's what I'm doing here. Once you import it, the next thing you need to do, you have to link it. You link it, or you connect them together. So to connect it, you're going to make use of this component macro. Let me put this thing here. This is where you connect your contract with the components. So this place is where you connect your contract with the component. And what you're basically connecting is your storage and your event. You're linking your storage and your event to that of the component. And what does it mean? The events in your component, you're making them accessible in your contract. The storage in your component, you're making them accessible in your contract. That is what this line 15 is doing. So you see the same way we imported Oneable components here. Let us now connect or link our contract to Oneable. So what we just do is you come here and you say components, which is a macro. Inside here, you first say part. Part, you're saying, I want to link the part of what you want to link is this Oneable component. So I'll copy it and paste it here. Now, which storage am I linking it to? I will now come here, I'll call a name of my storage. I can call this storage Casweeney. let me just call it ownable, but it can be any name. I'll call it ownable, right? And I'll say this is, remember, now we are dealing with ownable components. So I'll say ownable components, colon, the storage of ownable components. That's what I'm linking it to, right? So that means here now, what I'll put here inside storage is, when I say storage, I'm going to say colon ownable. Similarly, for events, I will say ownable event. A lot of time it's good to just use this pattern so that everything makes sense. Okay, I've not added this, so I need to add this. The reason why it's complaining is because I've not added sub storage. You see the compiler is showing it, so I need to add this sub storage to read, because this is not our main storage. This is from components. So similarly, you're going to also create an event. Sorry, you don't need to create an event. Just inside here, just copy this guy here and link it here as well. Say ownable event colon, which is equal to ownable component colon event. Now we are done with the linking. So this, what this just does is, okay, this is my contract. All the storage in my component, I'm making it accessible in my contract. All the events in my component, I'm making it accessible in my contract. That is what this guy is doing. That is just what this guy is doing. But now you only linked it. You don't have access to the functions in that component. And the only way to have access to the functions in those components is to embed, which is now the fourth thing. First is to install the dependency. Second is to import. Third is to link or connect. And lastly is to embed. And the embedding, you just understand the syntax of how to embed. You don't need to stress yourself. Just know how to embed. Now, see the way I embedded the ERC20 stuff and all of that. To embed this guy, all I need to do, I'll say import. I'll now say ownable. This name can be anything. Ebuka, I can just say Ebuka ownable, right? It's equal to, this is where it now matters. This component, you paste it, colon, which of the embeddable do you want to embed? And the only way to know the embeddable you want to embed is to go to OpenZeppelin and find it. So if I go to OpenZeppelin, I'll go to access. This is access. This is source. This is ownable. This is ownable component. Now, this is the component. What am I embedding? This is what I'm embedding. Anywhere you see embeddable app, this is what you want to embed. This one now. So this is what I want to embed. So I'll now copy it, come back here and paste it. And you also need to pass in your contract state because they are sharing state. So you pass this guy there. And that's all. That's all. But now, this stuff imported here is not available to be called outside. Let's see. Can we call, okay, this is embeddable, so we can call owner, we can call transfer ownership and all of that, renounce ownership. So for it to be callable outside, you just need to add this attribute on top of the line where you're doing the embedding. That's all. This is all you need. This is all. There's nothing else. Like this now, this contract has transfer ownership, owner and everything in this contract. That's all. Oh my goodness. Are you guys still confused? Yeah. So I know, I understand. It's normal. It's normal. So the reason why I did this summary is because I just want to show you the steps. So in everything, it's just 4 steps. Or let's just say 5 steps. Let's just say 5 steps. So since this stuff is being recorded, let me just add the steps here. Let me just add it here. So let me just copy this guy, paste it, bring it down there, right? And I'll say steps to embedding a component. Or let us steps to using a component in a contract. Right? So let's go. Let me pick this guy, duplicate it. No, sorry. Duplicate this guy, Control D. Duplicate, yeah, now. You should. Okay. If somebody doesn't know how to use PowerPoint again. All right. So I'll just get rid of this guy. Pick this guy here. Sorry. Get rid of this guy as well. Take this guy up so that we have enough space. Yep. All right. So the steps, let's go. Bullet points. Number 1, add dependency to your package. So a package is that your SCAP package is scaffolded, right? That SCAP package is scaffolded. Example of a dependency. There are many dependencies, but example is Open Zeppelin. Yeah, packages. So just add it. Step 2, import the components. Import the components you intend to use, right? Using the Control B use keyword. You know how to import in Cairo now. You make use of the use keyword, right? Then 3, link/connect the contract storage and event with that of the components from using the components macro. So let me bold this guy using the component macro, right? Then 4 is embed the embeddables you wish to use in your contracts, right? Lastly, if the functions in your embeddable are expected to be called externally, right? Use this attribute. Where is it again? Use the hash, control B. Use the hash square ABI into embed underscore V0 attributes to add all the functions in the embeddable to your ABI. So what this does is it makes all the functions in that embeddable available in your ABI. And you know it is from your ABI you have access to the functions and all of that. So this is just what you're doing. The reason why it looks confusing is because it's a lot. It's a lot. But once you understand it, it's very easy. It's very easy. So does this make sense so far, guys? Hello, guys. Are you with me? All right. So we are not able to go through, we did the 2 out of the 4 things we are supposed to do, and I know we wouldn't be able to finish up. So in our next session, we are now going to learn how to create a component. You see this component we are using now, we used here. We are going to learn how to create our own component and use it, right? So this is like this. Now we are done with today's class. We are done. I'm going, the article is in the, let me just drop it here. So let me quickly drop it. So in this article, you understand how these guys work under the hood. Although when we start creating a component, I'm still going to explain it for you guys, right? So, but you can read this before our next class, so you get to know what's up. So let me share this guy with you here. So it's also in the slide as well. All right, so I'm sending it here. So please, I think it's time for you guys. I'm coming back to my slide, and let me go back to my slideshow, and we are here. Do you have any question? Ask questions now. Oh, this was a lot. Why is everywhere quiet? There are no questions. All right. If there are no questions, you can unmute your mic. You can unmute your mic to ask these questions, though. But if there are no questions, I think I'm going to hand over to Paul or Sarah. Yeah. So that's basically all.
Yeah, thanks for the class, man. I'm seeing a comment here. Someone said they're kind of like confused, but then that's why we are doing these classes twice a week. So if you are confused, you should go back when we upload the video tomorrow. You should just go back, watch it, then come back with your questions on Thursday, and also have a read at the materials that Casweeney shared. I mean, it's going to be quite helpful because it's understandable that you can't really grasp every stuff like in 2 hours. It's understandable. But then get prepared and show up for the Thursday class. So looking back at last week assignments, we kind of realized something. We realized that some people I've just been like copying, pasting here and there. I mean, it's okay to just complete your assignment, but then it's also another thing to learn from what you're doing. You understand? So we actually encourage everyone to do this assignment by themselves and kind of like avoid copying them from someone else's like GitHub. I mean, it wouldn't help you basically. It's just basically us trying to say, okay, if you actually understood, or maybe if you actually like grasp everything that was taught throughout the session. And yeah, basically the submission form was actually meant to close this night, but based on the form right now, it's currently extended to tomorrow. So if you have not submitted the assignments yet, you should try and work on it and submit tomorrow. And as well, pay attention to not copying other people's work and just use your hands to like do this assignment and yeah, so you have enough knowledge of what you're doing. And next class will of course be handled by Casweeney, which he would touch a few things that maybe got some people confused in this session, and as well handle how to build a token sell contract in the next session, and also upgrading contract. So all this stuff is I mean, just like the headline for today's session is more of advanced, but like I said, it takes time to grasp all this. So take your time, understand, and get prepared for the next class. So if we don't have any question, we'll call it a night. And thank you all for joining. I mean, it's not easy to keep on turning up and turning up and turning up. Thank you for joining, and see you on Thursday. And thank you, Casweeney, as well.
Thank you.
Yeah.
Thank you, everyone.
Yeah.
So please, everything you need to know about, so I'll just share the slide. So this guy, everything you need to know is properly explained in mastering composability and components. So maybe before next class, I try to read it and all, so you get to understand a lot of things. Yeah. So
Okay.
I feel like the reason why most of you are still confused is because we are using components. But normally the two extra things I was supposed to do was to teach you how to create components, and in that process, you get to know why some of those things we were using are important. But come next class with open mind, please do well to read this content so that next class you won't be confused. Thank you very much. All right.
I don't know if you have like 2 more minutes of your time. Collins kind of have a question too. He wants to
All right, sure.
for the assignment, are we implementing a mention method in the form? Yeah, pretty much. You're going to like do every stuff mentioned in the form. That's what the whole question is there for. But Collins, do you have another question that you wanted to ask Casweeney? Okay. Yeah, that's it. Thank you, Casweeney, for your time today, and see you on Thursday as well. Yeah, good night.